Okay, hello everyone. My name is Masoud Fatollahy. I'm working as a senior solution engineer specialist on WinRiver, and I have my colleague here.
I don't have a mic, so you can present me.
Yeah, he's Hans-Olov Ericsson. He's also senior field application engineer. We are here today actually talk about the edge, a little bit about ourselves, who we are, and then digging into the edge computing and very roughly describe what is edge computing and why is needed today. Then we go into the solution for the edge computing that today is OpenStack based and is a part of the OpenStack foundation, that is StarlingX. And also we're talking about Akraino, that is also a project under the Linux Foundation that is also focusing only on edge. So we discuss this stuff and say how we can use that and what this project is about. So I give you to Hans-Olov.
Thanks a lot, Masoud.
Thanks.
So just going to say a few words about, I think it's good to have the background, what Akraino and StarlingX is origin from. So I'm going to talk just a little about who we are and what we're doing. So do you have, is this one? All right, let's very quickly for those. So I usually ask people who knows about WinRiver in this room. Can you please raise your hand? Just a few of you. So that's good to have a background. So WinRiver is really originating from the embedded industry. So we go back into 1891 where we were founded as a private company. Then we went public in 1993, and then we were acquired by Intel. So from 2009 to 2018, we were part of Intel. But now we are also back to being a private-owned company again, I would say. So when you talk about our position in the market, we are actually the market leader when it comes to embedding operating systems. So that's where we started and coming from. So if you heard about VxWorks or embedded Linux, that's where our sort of roots are in the beginning. And we are market leader on both of those. We have like 30% of the embedded RTOS market worldwide, and we have like 50+% of the Linux embedded market. Little about our verticals, the customers, read for yourself. We're quite big in aerospace and defense. We are quite big in network infrastructure, so that's something we're going to focus and talk about today. And we're also big in the industrial market. And interesting enough, when you're talking about cloud and edge cloud, you see the two markets, networking and industrial, sort of merging. I'm going to just mention a little few about that. That's quite interesting. A little about our product portfolio. So we're coming from the small devices. We have IoT. We worked with IoT before anybody know what IoT was. So we're working with small devices, connected devices, real-time devices, and we have products covering everything up to the network infrastructure and everything between that, you can say. All right, so edge computing, for those who doesn't really know what it is. So edge is very easy. It's just putting the cloud nearer to where the source of the data is. And the reasoning behind that is that you want to get close to the data for many reasons, but most of it because it's something that is limiting you to access and work with the data. If you put everything in a public cloud and try to access local data, you have delays and other things around it. So we're talking about edge, and the network edge, that's usually something that means different also for different types of companies. So if you're talking about the telco edge, it's like where you have the edge routers, where you access things. But if you're talking about the edge for industry, it's more like on the device side where the devices are connected. And the important thing also, it's not the same as IoT. IoT is more about collecting the data and connecting the devices, and edge computing is more about the compute part of it. So why do you need edge computing? Well, as I mentioned before, it's more about getting closer to where the data actually is happening. And there's two compelling reasons for having edge computing. One is that you have to bring down the latency, the delays in the system. And if you try to do something in a public cloud where the servers are centralized, that's not nearly good enough when it comes to edge computing and our industry. So for instance, if the speed of light is quite a limiting factor. So if you instance, looking at putting a server just a few miles away in a Swedish town called Norrköping in the middle of Sweden, you have like 1 millisecond round trip latency just to access that in speed of light. And if you put the servers in the center of Europe, you have 10 milliseconds. If you put it in Australia, you have 100 milliseconds in latency. And that's not good enough when it comes to edge computing. So that's why you want to put the source of the compute power much closer to where the data is generated. Another thing is, of course, bandwidth conversation. You want to have the bandwidth that you have available. You want to use it for useful data. And if you deploy 1 security camera, no problem at home. If you deploy 12 security cameras, you will have an issue with bandwidth. And that's what we're talking about here. Trying to compute and make the first pass of analytics out in the edge, and then try to transmit as little data as needed as possible. And this is also important when it comes to things like video streaming and these kind of things, because I think I read a report quite recently saying that 60% of the bandwidth of the internet today is streaming video. And of course, that is a problem if you want to sort of grow the streaming video business and make it bigger, and everybody's doing Netflix, Facebook video stream and stuff like that. That's going to be a limiting factor. So you have to take care of data much closer to the source of it. This is another thing that we think is powering edge computing. Automation, PC automation, cloud, near closer data, robotics, artificial intelligence, machine learning, these kind of things. So for those who don't already knew it, we're probably into a paradigm shift. The problem with the paradigm shift, if you never know why you're there, but we think we are there. I think we are now in the midst of the 4th industrial revolution, where we're trying to replace human work labor on the industry floor with automation. Other kinds of services also be replaced. I saw in some kind of research saying that 50% of the work that we think are there today is going to be replaced by artificial intelligence and robots. So that's where we probably are. It's all about connecting devices. And one big driver for that is infrastructure and connectivity, and also wireless communication. So 5G, the things that you see happening now with Ericsson and Nokia and other companies, is a very, very important means of doing that, because 5G doesn't only mean that you have better capacity on the radio. It also means that you have lower latency, faster connectivity, shorter terms of connecting people and devices to each other. So man-machine and machine-machine communication is going to be a very big driver for that. This is an initiative from ITU called IMT2020. It's interesting. So IMT 2020 is looking at the use cases for 5G and see what you can do with it. And what you see now, if you look at the papers, you see that Ericsson has sold a lot of new 5G into the US and stuff. That's all about the top part of it. So that's about increasing the bandwidth of the radios, making streaming video available for big dense cities like New York and other things in the US. That's the top part of it. And then we'll see the massive IoT deployment that's also going to need a smaller radio, but that's a different use case. So they're going to use low power devices, lot of connected devices. That's when you heard the CEO of Ericsson talking about 50 billion connected devices. That's the lower left part of it. And then we have what we think is the most interesting part, and that is the closer to the edge, the high availability and low latency thing. So this is also going to be handled by something in 5G called slices. Probably people in the room know more about slicing than I do, but slicing is going to be very important, because that's a quality of service definition on what type of use case you're going to use 5G for. So 5G is a very important driver also for edge computing. So this is just an example of an edge compute for autonomous car, how it works. You will have local compute power in the car, but there's a limitation how much compute power you can have in a car. And you also have the means and the necessity of communicating and collecting traffic data, traffic situation, things, and making computing in the cloud, and send it to the next car, can take the advantage of that and these kind of things. So this is like an edge computing use case that we see today, but there's going to be much, much more of them in the future. Okay, Masoud?
Yeah, thank you. Any question for Hans?
Yeah, sure.
Yeah, thank you, Hans. Okay, now from Hans we know what is edge computing and why we need the edge computing. Hopefully there is a lot of discussion ongoing about edge computing, and it's going to be usually everyone trying to find a killer app or killer use case for the edge computing, and this is not clear yet. So the only thing that everyone aiming for is latency, performance, security, quality of service in the edge. They know that it doesn't matter which use case you're going to use, you need those 4 features. That is a gap today for OpenStack. This is where actually the StarlingX comes through. This is actually the StarlingX is based on our Wind River Titanium cloud solution. This actually focusing mostly on edge, but it can be used in the core and data center too. This is launched in May 2018 in Vancouver, OpenStack Summit. That is actually integrated platform. That's why I say is focusing for high availability, security, quality of service, performance, and low latency. These 4 or 5 gaps, that is actually the main extension we put to the OpenStack. What the StarlingX is going to actually use is going to use as a first initiative is going to base on Kubernetes and OpenStack, starting with those, and also he's under the OpenStack foundation that we heard today that he talked about the edge. So StarlingX, I actually went through these gaps, but this is a summary. It doesn't matter is a telco or is an industry, because we know that there is a use case that requires those gaps. There is a use case that requires solution for those gaps. And what StarlingX start with is actually is proven that it works because it's based on a 5th generation release of our Titanium cloud that is in production, that customers are using it. So it's proven that it works, and this is all include all the feature that fulfill these gaps. Like he actually has a scalability that is, you can start with 1 server, have the all-in-one server. You can have 2 for high availability, or you can scale up to hundreds if you want it. So it's very scalable from 1 to many servers. Then, as I mentioned, is deliver latency, is actually have a best performance for the edge that I'm going to touch a little bit later on. Then when it comes to the installation and commissioning, it's also very, very easy to install and actually building up the system. Very easily, very less time you use just building it up. You don't need to have days or actually weeks. It's just a matter of minutes or hours to building up this system. Then, of course, we're going to provide the end-to-end security and the low latency that we need for the edge application, and is 100% compatible with open industry and open actually standard. And is also supporting the multi-layer software and hardware decoupling. So if you want to go 3 decoupling system, or if it's required for your application, your use case, this is what is supported. They're totally decoupled from each other, from the application, from the middleware, and with the hardware. And of course, I should mention that this actually software is already validated in OpenNFV. I don't know if you are familiar with OpenNFV, that there all the vendor comes and the application comes together and try to test the different application from different vendor and to see the compatibility between those, at which infrastructure, which software, OpenStack software can support most of those applications. That is what we pass as a first infrastructure solution. So if we take a look at what we can do with this Titanium cloud, or now is StarlingX, is that we have just one structure, but depending on the use case and the place you want to put those, you have different actually software product. You can generate it from one structure, architecture. So if you going to have as a service provider or data center, there is a solution that we call actually Titanium Core. There you have a multi-rack solution with hundreds of compute nodes and that stuff. Then if you go closer to the edge to have a solution that is one server solution that is just one solution, one server that include both control, storage, and compute node. So you don't need more than one to start your application, onboarding your application for the edge. If you want to have high availability for your application, then you put two. You don't need more than two. So two are going to give you high availability both from the hardware, software, application, and all the services. Then, of course, we have another flavor that is aiming just focusing for the industry because they have different requirements compared with the data center or with the telecom. This is I covered. You can have a single solution that include all compute, control, and storage, or you can have a duplex. That is the two servers that include actually. This is the same as the first one, but you double it just to make sure that you have a high availability for the hardware and all the services. Then you go actually from 4 up to hundreds if you wanted to. When it comes to the security, what is covered in the StarlingX is actually end-to-end security. This is from the hardware security up to the host and going to the OS that you sign the kernel, sign all the modules. You go to the networking, you have the firewall, and you have an encryption for the databases and that stuff, that you have a security in place there. And if you come into the hypervisor, then we provide the virtual TPM for the VM, that you can actually VM see this TPM as a hardware TPM. It's a virtual TPM that is provided to authenticate the guest that you are running on that. The system overview like this. In the control plane, as I said, we are going to use Kubernetes and OpenStack and put the StarlingX services there that is missing in those projects or those products. Then for the storage, we are going to use Ceph as a backend. And for the compute node, you have a different flavor. If you want to use bare metal, only container is possible using Kubernetes. Run the container in one compute node. Another one, you want to use KVM. So you can have that possibility to coexist different compute node that fulfill your application. If you want to have isolation for your VM, your application, then you need to run it on the VM. Of course, have one compute node that run the VMs. And if you go into the microservices, of course, use the compute node that has the container and support for the container, for the bare metal, running in the container. Then the networking is, we are going to use Open vSwitch as and also CNI for container. And leveraging the PDK from Intel to give the high performance for the application. And also you're going to be actually support the SIOV and PCI pass-through, of course. If you take a look at the software stack, we as I say, for the hardware, we are going to use a secure boot and TPM. Then we put the operating system. Today we are actually using CentOS as an operating system, and added the extension that is needed for actually have support for the real-time application, give you the performance and also security you need, and also the latency, because you need to set the right parameter for your operating system to support the right latency for your application. Then on top of that, as I say, we are going to use Ceph as a storage backend. Networking is Open vSwitch and SIOV and PCI pass-through. And we also provide the accelerator to the VM. So if you want to access the GPU or any other accelerator, crypto chip, or any PCI-based chip that you want to have actually access to the VM, so you have possibility to provide it to the VM. That is also missing to that we talk about, that it is on the way to add this stuff in the OpenStack too, that we have supported for. But we have already those included in the StarlingX. So StarlingX services actually is a services that play a role as a middleware in this case. So we're going to include the host management, include the configuration management, software, fault management, security management, service management that is taking care of the middleware between the software and the hypervisor or Kubernetes that we're going to use. So StarlingX going to be the container platform. That means that you are going to run container on top of this StarlingX services. And going to actually support with the support of Helm and our Armada for the airship for automation. Then actually we are containerizing the infrastructure orchestrator, and also the OpenStack services is actually running on the container today. So I'm going to dig in a little bit for each of those and describe what is actually doing in each of them. The project is actually a structure is that all the services, we find that it's better that we have a sub-project. So it's going to be the small project for each of the services, so that we have a team that work with each of these projects separately. And actually put this source code to the integration project that's going to be used both the package or different feature and product from the upstream project, and also as you can see, we have a StarlingX staging GitHubs that contain the extension we add to the OpenStack. And those extensions going to be provided to the integration project, and also at the same time going to be upstream to the OpenStack. That the next time we would pull the OpenStack, we have all the extension there. We don't need to have it locally in this file. For each release we don't actually using from the OpenStack, we add new feature, new extension, add it to the integration project, and push it back to the OpenStack too. In this case. For the container platform, as what we have done, we actually added the high availability for this Kubernetes master. You're going to run in the two controllers, and also using this Calico network container network interface plugin. To provide the networking for Kubernetes, we including the Docker runtime, using the Ceph as a backend, as I mentioned before. And what we added, we're going to add the authentication and authorization for Kubernetes API. So we are using the Keystone to actually provide this security between accessing the different service or different Kubernetes APIs. And also that for the local, we are using the local Docker image registry, and there also we're using the Keystone for security accessing this local registry. Helm is the package manager that is used today, and Airship Armada is using for orchestrating and deployment of the different chart of the Helm. So Helm making the package, and Airship use those package for deployment and deploy this. The whole idea about Airship and Armada using this way is that we are actually, our goal is to provide the zero-touch provisioning. We don't need to do anything. Everything should be automatically deployed. Then actually our initial hosting going to be the Kubernetes. The Kubernetes hosting environment for all the applications. So Kubernetes is going to be the base in this case. When it comes to the actually infrastructure and the OpenStack services, in the initial release that comes actually this month, end of October. So we are not going to containerize all the services from the StarlingX. Here, this is actually named as the flock. That it calls the code name is the flock for the StarlingX services. So some of those going to be containerized, but not all of those. So in this case, you can see that we are going to, because of this, we need to have one instance of Keystone actually running as a bare metal to support these services. And we have also going to have a Keystone as a container for the other services too. And we need one instance of the Horizon too, because those services is included in Horizon. And we need to have those also in one instance running in the bare metal. When it comes to the OpenStack, as I say, actually the community had done a lot of work during this 4 or 5 months to actually run all the OpenStack services in the container. So all of those are containerized, and today is based on Pike. But we see what happened next. So I'm coming back to the releases, what the plan for releases. Then the Nova API proxy, that is actually orchestrating the compute nodes going to be containerized, because all the compute nodes going to be as a worker, the container worker in this case, node, container node. Then the fault management also going to be containerized to provide the alarming and that stuff for the OpenStack that's running in the different containers. And Keystone also going to be run, the Keystone container part going to be run in the OpenStack namespace, just to support the OpenStack, not other actually the feature or their APIs to only provide the services for OpenStack services. If we take a look at compute node, we have seen actually, as I said, the compute node going to be as a Kubernetes worker nodes. The Nova compute and the Libert going to run on the containers, and also the Neutron agents that taking care of the networking going to be run on the containers. And Telemeter too. So these four main actually services from OpenStack that or virtualization going to run on the containers. We couldn't do actually run the Open vSwitch DPDK in the virtualization because the Helm doesn't support it yet. So if Helm support that, they're going to be also virtualized and running on the container. The StarlingX that comes from our Titanium, because in Titanium solution we had a support for distributed cloud, that you have one central controller region that actually can manage all the sub-cloud in the different region, and those communication between the different regions based of layer 3 networks. And since we are sharing the services from the system controller in the central, then you need less actually services from OpenStack running in the edge. So you're going to be much lighter version of the OpenStack or that is running in the edge. What's the status today? Today is actually we have 100 active developers that developed this project, and there is a repo for this one that you can actually access all the sub-projects I mentioned, and also see the status. And you have also today you can actually download this and compile it, build it, and run it if you want it. This is everything is there. As I said, the first release is going to be end of this month, so it's very exciting to see that release. We are going to talk. Our engineer going to be in Berlin talking about this. It's the next month. There we can see exactly can see what they are going through all the steps to show how you build it, how you can use it, how you install it. So that's very good to be there if you are interested. So next is Akraino. So Akraino is all about edge. This is under the Linux Foundation. That is also, we are very active there. What is this is that they're going to take care of the application as for all the use cases that you need for the edge, depend on which use case you have. Going to develop those application, include those in the ecosystem, and use it when you're trying to create a blueprint for your application or use case. He's also developing and including all the middleware. This is what we come in from the StarlingX. I can show you later on, and make sure that the APIs is interoperability in place, that you can run different cloud and connect different cloud together, not just one cloud or another one. So the API should be a totally open standard that everyone can connect and use as a middleware. Then I also include the full life cycle for development. They also include the CI and CD, that the continuous integration and the delivery, and also tool to do that. And also this is based on upstream collaboration. This is the base on all the project that is included on the Linux Foundation. Actually, the main goal here is that you make end-to-end automation and orchestration for your use case, for your product, or for your blueprint you want to use. That you don't need to do anything. That's why include, depending on your use case, include necessary packages, necessary project, necessary product, include that, build it, test it, and provide a blueprint that you can use directly on production. What comes to StarlingX and Akraino, as you can say, I describe Akraino, actually in this case, pool the services or OpenStack project and pool the stuff that he needs from different non-OpenStack project or other selected project that he needs to provide this edge blueprint. So in this case, you're going to actually use StarlingX, you're going to actually use container, and also OpenStack and some other upstream project like Ceph, Linux, DPDK, open source, Open vSwitch, and for orchestration include the UNAP. I don't know if you are familiar with UNAP or not. So it create the blueprint. So what if you talk about the blueprint, depending on your use case, in this case, it can be actually use case as a telecom 5G use case. It can be in the access, running the RAN or PON or IoT devices, or using the universal CPE. You can see, depending on those, actually select the different hardware. In the first one, maybe it's a single to multi-rack is needed. In the second one, that's the real time, maybe you just need one or dual server. So you select those stuff, select the code you need, select the project, and build the blueprint for you. That blueprint going to be the one that you can directly install and use it in production, because it's going to be actually tested. You're going to be proven that it works. You include the lifecycle support, and it's going to be production quality of those ones. So the benefit for this blueprint that comes from Akraino is going to be low cost, larger scale. You can scale from 1 to hundreds, and zero touch provisioning, that I say that this is very important. And this is going to be adept both for industry, telecom, and whenever need this kind of solution for the edge. Right now we have actually members that is working with Akraino, is very active in the Akraino. You can see the name like Ericsson, Huawei, AT&T, Juniper, Red Hat, Intel, Nokia. So those are behind this and is working actively with this project to make sure that the blueprint that comes out is a blueprint that can be production ready and use it directly. So this is the a link. If you need more information, you can actually go through these links. I'm going to provide these slides later on. Maybe you can share it with you if you are interested to have these slides. But what this project needs is actually needs you. If you are interested to be part of this development, go there and actually be the part. Join this project and be the part that make it different for us in the future. Thank you very much. If you have any questions, so
yes, thank you, Masoud.
Thank you.
If there are any questions, I'll pass on the mic.
Everything clear.
Anyone?
Clear.
No one? There's one question.
So I'm interested. I've been following the airship stuff for a while, which has a very similar undercloud architecture with that you're using. Is there an intention to maybe bring some of the flock services into a way that they could be consumed by other deployment and undercloud solutions?
As I said, these services, this is open source, right? So it's going to be services that can be used by OpenStack or Kubernetes. So it's going to be both of those can leverage the services. So those are there. If you have a project that needs those services, just pull it and see which version of OpenStack or Kubernetes is there. Use that version, then you have those. Just apply it. There shouldn't be any problem to apply it to any other cloud services. I think somebody says this morning, if you want to understand it right, be the part of this. So if you go into the part of this, trying to develop something or just contribute something, then you learn how you can actually mix and match and move services between different clouds.
Okay. Any other questions?
Thomas, any questions? No? Yeah?
There's just needs time.
I see only AT&T here as an operator for mobile, and there are more edge stacks that are not Akraino or StarlingX. So.
In the Akraino list? Yeah, actually, as I say, Akraino is also new. This is started I think in the beginning of this year. It was May or April, right? So the decision was, I think we went out and asked who want to be the part of this in the beginning. So AT&T and Intel was the part that forced, say this is very interesting. They started, and then we're going to grow. I'm sure that there's going to be more operator there, but yeah. So. You're talking about the orchestrator, that is, you are using OSM and you are using ONAP, or no, they don't have it. I don't see that they have actually. They are using the system integrator for this stuff today, but they are going to be also part of this soon. I'm sure they're going to be more and more involved, because this is right now is very hot and it's new. But everyone going for or later find out that this kind of feature needed. It doesn't matter which use case you want to use. In the edge or in the data center, you want to have security, you want to have high availability, you want to have a low latency, not just edge. So you're going to be more and more that going to be involved in this project, hopefully.
Okay. Well, thank you very much. We have a short coffee break, and we'll be back here in about 15 minutes, 2:45.
Thank you. Thank you.